The Netherlands sits on the Rhine-Meuse-Scheldt Delta, a low-lying coastal plain formed by millennia of river sedimentation and North Sea tidal action. Over 26% of the country lies below sea level, making it one of the most flood-exposed nations on Earth. Its temperate maritime climate brings heavy rainfall and storm surges. Rotterdam, Europe's largest port, faces the dual threat of river flooding from the Rhine and sea level rise from the North Sea. The city's Room for the River program sets back dikes, restores side channels, and creates floodable parklands. Water plazas double as recreational spaces during dry days and retention basins during storms. Floating neighborhoods move with water levels. The Dutch have reduced major flood risks by over 80% through these innovations. China spans vast climatic zones from subarctic to tropical, but its monsoon climate delivers concentrated, intense rainfall to most major cities. Rapid urbanization has paved over natural drainage, worsening flood risks. Since 2015, the Sponge City program has integrated green, blue, and grey infrastructure to absorb, store, and reuse rainwater. Pilot districts in Wuhan cut flood incidents by roughly 60% through green roofs, porous streets, and subterranean tanks. The program enhances urban biodiversity alongside stormwater management. By 2030, 80% of China's urban areas will be sponge-like. Abu Dhabi sits on the Arabian Peninsula's hyperarid desert coast, formed by ancient marine sedimentation and wind-blown sand deposition. Summer temperatures routinely exceed 45 degrees Celsius, with minimal rainfall and intense solar radiation. Masdar City, masterplanned by Foster Plus Partners and conceived in 2006, reinterprets traditional Middle Eastern urbanism, narrow shaded streets, wind towers, and mashrabiyah screens, combined with photovoltaic canopies that generate energy while cooling the streets. Street temperatures are 15 to 20 degrees Celsius cooler than the surrounding desert. The city serves as a living laboratory for passive design and sustainable technologies exportable worldwide.
Setúbal lies at the mouth of the Sado River on Portugal's Atlantic coast, where runoff from nearby hills meets ocean tides. The city's Mediterranean climate brings dry summers and intense winter rainfall, often coinciding with high tides to create perfect flood conditions. The 19-hectare Parc de Varzy retention basin holds 240,000 cubic meters of water, equivalent to 100 Olympic swimming pools, regulating flows from the Livramento and Figueira streams. During recent extreme storms with 20–25 millimeters of rainfall in a short period, the basin filled to less than 50% capacity, successfully protecting the city. The €1.28 million project, co-financed by EU funds, demonstrates the tangible value of anticipatory adaptation.
Berlin sits on the glacial sands and gravels of the North European plain, formed by Pleistocene ice sheets that left a flat, sandy landscape with low natural water retention. Its temperate continental climate brings summer cloudbursts that increasingly overwhelm its century-old sewer system. In 2018, Berlin embraced the Schwarmstadt, Sponge City, paradigm. A massive cistern 40 meters across and 30 meters deep now holds nearly 17,000 cubic meters of stormwater near Unter den Linden. Neighborhood pilots pair green roofs, permeable pavements, and fee rebates for buildings that retain runoff, steadily transforming policy into street-level hydrology. Addis Ababa sits on the Ethiopian highlands at 2,400 meters elevation, formed by volcanic activity along the East African Rift. Its high-altitude tropical climate once moderated temperatures, but rapid urbanization, growing at 3.7% annually, has replaced natural spaces with heat-trapping concrete and asphalt. Busiest neighborhoods now register temperatures over 40 degrees Celsius. Green corridors and urban parks now serve as the city's strongest defense against climate extremes. These nature-based solutions trap less heat, absorb storm runoff, and clean the air, offering a scalable model for Africa's rapidly urbanizing cities. Aarhus lies on Denmark's Jutland Peninsula, a landscape shaped by glacial erosion and post-glacial rebound. Its temperate oceanic climate brings frequent, intense rainfall events. The Risvangen neighborhood project is Denmark's first large-scale example of separating rainwater from wastewater and handling stormwater with nature-based solutions in a residential area. Rain gardens, permeable surfaces, and green corridors manage runoff directly on site, reducing pressure on sewer systems and preventing urban flooding. The project proves that climate adaptation can be retrofitted into existing neighborhoods, not just new developments. Barranquilla sits on Colombia's Caribbean coast at the mouth of the Magdalena River, a delta formed by millennia of river sedimentation. Its tropical savanna climate brings distinct wet and dry seasons, with heavy rainfall and vulnerability to storm surges. The city has transformed its approach to climate resilience by integrating ecological restoration into urban planning, demonstrating how nature-based solutions can drive social and economic development while protecting against floods and extreme weather. The model has inspired other Latin American cities to pursue similar integrated approaches to climate adaptation. Ahmedabad lies in western India's semi-arid Gujarat plain, formed by alluvial deposits from the Sabarmati River. Its hot semi-arid climate brings scorching summers with temperatures exceeding 45 degrees Celsius. The city developed a heat action plan model that strengthens early warning systems, improves healthcare readiness, increases green cover, and shifts work schedules for outdoor laborious. Cool roofs reduce surface temperatures by up to 22 degrees Celsius on concrete roofs. The model has been replicated across India and South Asia, proving that low-cost interventions can save lives in extreme heat. Guayaquil sits on Ecuador's Pacific coast at the mouth of the Guayas River, a delta formed by sediment from the Andes Mountains. Its tropical monsoon climate brings intense seasonal rainfall, and the city is highly vulnerable to flooding. Projections indicate significant economic and social impacts from climate change. The Febres Cordero Parish project explores nature-based solutions to enhance flood resilience, using a collaborative, bottom-up approach with local and international partners. The initiative demonstrates that community-rooted design can make a measurable difference in the lives of those most at risk. Skellefteå lies in northern Sweden, just below the Arctic Circle, on a landscape shaped by the last ice age's glacial scouring. Its subarctic climate brings long, dark winters with temperatures plummeting below -20 degrees Celsius and heavy snowfall. The city is part of the global Winter Cities movement, which promotes climate-appropriate buildings and urban spaces for northern communities. Design choices account for extreme cold, e-parking must secure battery functionality, streets are oriented to mitigate cold winds, and infrastructure is built to withstand freeze-thaw cycles. Skellefteå proves that climate adaptation is not just about heat and floods, it's also about extreme cold. Xalapa sits in eastern Mexico's mountainous region, on volcanic slopes formed by the Trans-Mexican Volcanic Belt. Its humid subtropical climate brings heavy rainfall, making it prone to landslides and erosion. The City Adapt project implemented nature-based solutions with more than 6,000 plants and 3,900 trees to reduce landslide and erosion risks, improve water regulation, and restore watersheds. The project strengthens urban resilience while enhancing biodiversity and improving quality of life for residents, demonstrating that nature-based solutions work across climate zones and economic contexts. Belém sits at the mouth of the Amazon River in northern Brazil, a delta formed by the world's largest river system. Its equatorial climate brings intense year-round rainfall and extreme humidity. The metropolitan-scale project enhances resilience to flooding, heat stress, and biodiversity loss. It supports sustainable livelihoods through urban bioeconomy strategies, including strengthening agroforestry and supporting local businesses. The project demonstrates that climate adaptation in the Amazon Delta must work with, not against, the region's immense natural systems. Dakar sits on the Cape Verde Peninsula, West Africa's westernmost point, formed by ancient volcanic activity and coastal erosion. Its Sahelian climate brings a short rainy season with intense downpours and a long dry season. Mayo-based fall has prioritized flood management, air quality improvement, sustainable waste management, and nature-based solutions in neighborhoods. The 2026 Youth Olympic Games serves as a major catalyst for this transformation. Dakar's approach proves that major events can accelerate climate adaptation, leaving lasting resilience infrastructure for residents.
Jakarta sits on the northern coast of Java, a low-lying alluvial plain formed by river sedimentation from the island's volcanic interior. Its tropical monsoon climate brings extreme rainfall, while land subsidence, caused by groundwater extraction, exacerbates flooding. A spatial prioritization framework for vegetation-based climate adaptation offers a transferable model for evidence-informed adaptation in rapidly urbanizing tropical cities. The approach prioritizes green infrastructure where it delivers the greatest flood and heat reduction benefits. Colombo lies on Sri Lanka's western coast, within the Kelani River basin, where the land meets the Indian Ocean. Its tropical monsoon climate brings heavy seasonal rains that have historically flooded the capital. Colombo's wetland complex, nearly 20 square kilometers of freshwater lakes, Wet woodlands and swamps acts as a giant flood buffer. During intensive rainfall, these wetlands store several million cubic meters of water, the equivalent of more than 27,000 Olympic swimming pools. They also purify air, cool the city, and serve as carbon sinks. Since 2012, the Metro Colombo Urban Development Project has combined engineering and environmental science to conserve and revitalize these wetlands. 40% of Colombo's floodwaters drain into wetland areas. The wetlands absorb 62.1 millimeters more floodwater than built-up areas. Colombo was recognized by the Ramsar Convention as one of 18 world cities with globally significant wetlands. The city's transformation from flood-prone capital to wetland-protected metropolis proves that nature-based solutions can outperform concrete infrastructure.